Hello children, good morning. Today we will discuss about electroplating of an article with silver. In the previous video we discussed about electroplating of an article with nickel. So let us start how silver is deposited over an inferior article. Right? So electroplating of inferior metal or you can say article with silver is quite common. It is mainly done to improve their appearance and to give them a silvery white look, right? To perform this electroplating, you have to set an apparatus as I'm going to represent you all. Okay, you have to take a non-conducting vessel. Okay, non-conducting vessel, right? In this non-conducting vessel you have to immerse electrode. Okay, so here electrode will be a block of silver as anode and article to be electroplated is made the cathode. Okay, so a block of silver we will use as block of silver as a anode and article to be electroplated we will use at cathode, right? Then after, these electrode will be associated with potential with battery. Okay, so anode, right? This is negative terminal of battery and this is positive terminal of battery. Here cathode is cathode, article to be electroplated, article to be electroplated. Okay, and this is anode, a thick block of silver, anode, a thick block of silver, block of silver, right? And electrolyte we will use as aqueous solution of sodium argentocyanide. Sodium argentocyanide will be used as electrolyte. Sodium argentocyanide. Okay, so electrolytic solution is aqueous solution of sodium NaAgCN whole twice, right? Sodium argentocyanide. Okay, so you can see here setup is ready now. Setup is ready. We have taken a non-conducting vessel. We immersed the electrode. Here anode we used as a thick block of silver. Means here silver you want to electroplate over inferior article. So that's why anode will be of metal which you want to electroplate over the inferior article. So silver is used as a anode. Then after cathode we used article to be electroplated. Cathode is made up of article to be electroplated. And the solution we all know as per the condition of electroplating, solution should be of the same metal which you want to electroplate. That's why we have taken the aqueous solution of sodium argentocyanide. Aqueous solution of sodium argentocyanide is used as a electrolytic solution, right? So if you talk about the details of experiment setup and the process, so electrolyte I told you all. Here let us start now the process. Okay, so in the first point we will discuss about electrolyte. So electrolyte is here sodium argentocyanide. Electrolyte is aqueous solution of sodium argentocyanide. Okay, see sodium argentocyanide. Okay, so the electrolyte used in this case in aqueous solution of sodium argentocyanide, it can be prepared by adding sodium cyanide solution to a solution of silver nitrate until the precipitate formed just dissolve. Many times in the examination it is asked how sodium argentocyanide is prepared. So how it is prepared? It can be prepared by adding sodium cyanide solution. Let us take sodium cyanide solution. Solution of sodium cyanide we have taken NaCN. Okay. Add the solution of sodium cyanide to a solution of silver nitrate AgNO3, silver nitrate. Okay. Until the precipitate formed just dissolve. You will continue the adding of sodium cyanide solution to silver nitrate solution until the precipitate formed just dissolve. So after adding a precipitate of silver cyanide is formed, you will continue the adding of silver sodium cyanide until this precipitate dissolve into the solution. Okay, so further it will be continued. NaNO3 will form here. Further it will be continued. So AgCN will undergo a reaction with sodium cyanide NaCN to produce sodium argentocyanide NaAgCN whole twice. CN whole twice. Right? I hope you people understood how sodium argentocyanide is prepared. How it is prepared? It can be prepared, again I am repeating, by adding the solution of sodium cyanide to a solution of silver nitrate. This addition you will continue until this sodium cyanide, which is formed as a precipitate, dissolves into the solution. That's why we continued the dissolution of this silver cyanide with the sodium cyanide, and finally we got sodium argentocyanide solution. Okay, so this sodium argentocyanide aqueous solution is used as an electrolyte into the electroplating of silver on inferior article. Electrode, as I told you all, in the second point we will discuss about electrode. So here, as I told you all, anode is thick block of silver and cathode is of article to be electroplated. Article to be electroplated. Right? I hope you people understood electrode used in this process. Okay. Now come at the process and electrode reaction. Okay. We'll understand how the electrolytic process takes place. Process and electrode reaction. Process and electrode reaction. Electrode reaction in short I am writing, right? So the aqueous solution of sodium argentocyanide is taken in a suitable electrolytic cell, as I have represented here. You can see here we have to take the solution of sodium argentocyanide into the container. We have already prepared a setup for that. A block of silver is used as an anode, while terminals of battery through copper wires. Okay, a key and an ammeter are also placed in the circuit. Sodium argentocyanide, as it is dissolved into the water, dissociate as let us see how dissociation of sodium argentocyanide takes place. So if we talk about process and electrode reactions, first of all, sodium argentocyanide undergo dissociation. So NaAgCN whole twice undergo dissociation to form Na plus, Ag plus and Cn minus. Since the solution is aqueous, that's why water will also dissociate into the process to form H plus and OH minus. So after dissociation we got the following ion. We have Na plus, silver minus and H plus as cations, and Cn minus, OH minus as anion. So when the current is switched on, H plus, sodium plus and Ag plus ions migrate toward, okay, it migrate toward cathode. Okay, so here at cathode you can see cathode is here. So Na plus ion you can see here I'm writing Na plus, Ag plus, H plus, they all will migrate toward this cathode. But due to the lower position, silver will get deposit over this spoon. because silver is having lower position into the electrochemical series as compared to sodium plus and H plus. So preferentially here Ag plus will undergo discharge, right? So if we talk about reaction, you see reaction at cathode, okay, if you talk about reaction at cathode, reaction at cathode, as I told you all, at cathode silver will undergo discharge because position of silver is lower as compared to sodium plus and H plus ion. So silver plus ion gains one electron to form silver metal, and this silver metal will deposit over the spoon here used. You can see here into this setup, okay, this inferior article, spoon of inferior article will get a deposition of silver. So silver will deposit here, okay, so fine layer of silver will deposit here on this spoon to enhance the appearance of silver. This is spoon, right? So let us come now at anode reaction. Reaction at anode. Reaction at anode. Okay. We all know at anode anions migrate, and after dissociation you can see here we got Cn minus and OH minus as anions. Okay, so they both Cn minus and OH minus, here with the help of diagram we can understand Cn minus and OH minus, they will migrate toward anode. They will migrate toward anode. But none of these, neither Cn minus nor OH minus will undergo discharge, because here electrode is active, anode is active electrode. That's why itself this silver block anode will jump into the electrolytic reaction. Okay, because we all know ability of silver is greater to lose electron as compared to Cn minus and OH minus. Okay, so ability of silver of losing electron is greater as compared to cyanide and hydroxyl ion. That's why neither cyanide nor OH minus will undergo discharge here. Silver will change into silver plus by losing electron, right? And whatever silver plus will be formed here, that will compensate the concentration of silver ion into the electrolytic solution, because we all know most of the silver ion from the solution has been deposited here at cathode. That's why to compensate the silver ion concentration into the solution, whatever silver is undergoing oxidation here, that will compensate the quantity of silver plus ion into the solution, right? So if we talk about reaction at anode, so neither OH minus nor cyanide ion will undergo discharge. Here silver anode will jump into the electrolytic reaction, okay, to form Ag plus. Okay, so this Ag plus will compensate the concentration of silver plus ion into the solution. Okay, so if you talk about product at anode, nothing is at the name of product at anode. Silver plus ion, whatever is formed, that will balance the Ag plus concentration into the solution. This is all about electroplating of silver over inferior article. Okay, so I hope you people understood. Once more we can revise it, how the process took place. Okay, so to perform the electroplating of an article with silver, we have to set apparatus as I have represented in this diagram. take a non-conducting vessel. You can see here non-conducting vessel we have taken. Into this non-conducting vessel we kept the electrolytic solution of sodium argentocyanide. Sodium argentocyanide solution is taken here as electrolyte. Okay, into this electrolytic solution we immersed electrode. As per the condition of electroplating, we all know anode should be of a metal what you want to deposit over inferior metal. That's why we have taken anode of thick silver block, and the cathode is article to be electroplated. Then after we associated these electrode with the help of wire to battery. Okay. So if you talk about electrolyte is here, electrolyte is of sodium argentocyanide. Sometime in examination question is asked why not directly silver nitrate is used as electrolyte to perform the electroplating of silver over inferior metal. Okay, so always remember silver nitrate is poisonous, and Ag plus being easily reduced to silver even by air, and thus solution of sodium argentocyanide is preferred over solution of silver nitrate during electroplating of silver. Okay, again I am repeating why silver nitrate is not used, because it is poisonous. Because silver plus being easily reduced to Ag even by air, that's why sodium argentocyanide is preferred over solution of silver nitrate during the electroplating of silver. Okay, so here sodium argentocyanide we have taken as an electrolyte. Okay, let us see how sodium argentocyanide is prepared. Sodium argentocyanide is prepared by adding the solution of silver cyanide. You can see here we have taken silver cyanide solution to the solution of silver nitrate. This you will continue till the formed precipitate dissolves. So formed precipitate is silver nitrate. Okay, till the time this silver nitrate solution do not dissolve, we will continue the addition of silver cyanide. That's why again we added silver cyanide to sodium cyanide to silver cyanide, and finally we got sodium argentocyanide. Okay, so this sodium argentocyanide is used here as electrolyte. Anode, as I told you all, is of a thick block of silver, and cathode is article to be electroplated. Okay, then after let us understand the process of electrode reaction, or you can say electrolytic dissociation. Okay, so in electrolyte we used aqueous solution of sodium argentocyanide. Sodium argentocyanide dissociates into Na plus, okay, silver plus and cyanide ion, and water dissociate into H plus and OH minus. If you talk about ions present into the solution, we have sodium plus, Ag plus and H plus as a positive ion, and cyanide and hydroxyl as negative ions. Okay, so sodium plus, Ag plus and H plus will migrate toward cathode, but silver will get deposit over cathode. Why it is so? Because position of silver is lower into the electrochemical series as compared to sodium plus and H plus. So easily it will gain electron to undergo reduction. That's why here at cathode silver is formed. Okay, grayish white color silver will deposit on the inferior spoon used as a cathode. Okay, now come at reaction at anode. So we all know at anode anion migrate. At anode anion migrate. It means at anode what ions will migrate? OH minus and Cn minus will migrate at anode. OH minus and Cn minus. But none of these will undergo discharge, because ability of silver to lose electron is greater as compared to OH minus and cyanide ion. That's why silver will come from the anode to undergo oxidation, and here silver plus is formed, which will compensate the concentration of silver plus into the electrolytic solution. Okay, in this way electroplating of silver takes place. That's all for today. Thank you so much.